Hey everyone, welcome back to The Explainer. I am absolutely thrilled you're joining me today because wow, we are diving into something that literally sounds like science fiction, but it's actually saving lives right now. Have you ever stopped to think about how modern medicine is starting to act a lot less like a simple chemical and a lot more like tiny, programmed robots circulating inside of us? I mean, some of these pills literally have microscopic laser-drilled holes engineered into them just to pump out medicine. So today, we are going to unpack the brilliant science behind these marvels, controlled drug delivery systems, or CDDS. Let's jump right into it.
I want you to think about the old-school way we take medicine. You get a headache or an infection, you swallow a pill, and bam, you get this massive spike of the drug just flooding your bloodstream all at once. For a little while, you actually have almost too much medicine in your system. And then, a few hours later, you completely crash. The medicine wears off, the symptoms come back, and you have to remember to take another pill. It is just this endless, exhausting cycle of spikes and crashes. But what if your medicine was smart enough to actually dispense itself perfectly on a precise timer right inside your body?
Well, here is our roadmap for today to figure that out. First, we'll meet the smart pill. Second, the benefits of CDDS. Third, the manufacturing catch. Fourth, mechanisms of controlled release. And finally, the bottom line.
All right, kicking things off with Section 1, Meet the Smart Pill, defining the core concept.
Okay, so here's the official definition we're working with. A controlled drug delivery system, or CDDS, is a drug delivery system designed to release a drug at a predetermined rate for a specified period to maintain optimum drug concentration. Basically, the whole secret sauce is right there at the end. Maintain optimum drug concentration. The big takeaway from our source material is that the drug release is carefully controlled, rather than just dumping everything all at once into your stomach.
I like to think of standard medicine kind of like a flash flood. The dam breaks, all the water rushes in, it completely overwhelms the system for a minute, and then it's just gone. CDDS, though, it's a perfectly calibrated drip irrigation system. It's controlled and it's constant. It delivers exactly the right amount of medicine exactly when you need it, which ensures that the levels in your body literally never dip too low or spike too high.
Moving on to Section 2, the benefits of CDDS, or the smart alternative.
The advantages here are honestly massive. Because we're maintaining that constant concentration we just talked about, we drastically reduce dosing frequency. You're not popping a pill 4 times a day, maybe you just take one. And because of that, patient compliance goes way up, meaning people actually remember to take their meds. Plus, avoiding that crazy flash flood spike in the bloodstream significantly reduces side effects. The whole shebang leads to an improved overall therapeutic effect and much better bioavailability. Your body is actually using the drug efficiently instead of just flushing the excess away.
But of course, there's always a catch. Section 3, the manufacturing catch, the plot twist.
So if CDDS is so incredibly efficient and so much safer for patients, why isn't every single pill in your medicine cabinet made this way? Well, it comes down to some pretty stubborn logistical villains holding the tech back. First off, it requires a super expensive formulation. We aren't just pressing powder into a pill shape anymore, right? We're engineering microscopic delivery devices. That means incredibly complex manufacturing processes and highly difficult formulation design. I mean, getting a pill to dissolve perfectly over exactly 12 or 24 hours requires intense chemical engineering and extremely rigorous testing. And that brings us to the biggest, scariest disadvantage on the list, the dose dumping risk. This is exactly what it sounds like. And it's intense. Because you're packing an entire day's worth, or sometimes even multiple days' worth, of a drug into one single dose, you are relying entirely on that CDDS mechanism to act as a dam. If that formulation design fails, or say if the pill gets crushed accidentally, the patient gets hit with all of that medicine at the exact same time. That dose dumping can be incredibly dangerous. It's exactly why these systems require such rigorous, expensive manufacturing to get right.
Okay, let's actually dive into how these work. Section 4, Mechanisms of Controlled Release, Looking Under the Hood. This is where the engineering gets truly fascinating. Based on the source data, CDDS is broken down into 4 main types, and each one basically has its own mechanical superpower. We've got rate-controlled, which controls the speed of the drug release, dissolution-controlled, which relies on the dissolving rate of the materials, osmotic-controlled, which actually leverages water pressure, and finally ion exchange-controlled, which uses chemical swapping. Let's look at each of these briefly to really grasp the genius here. First up is the rate-controlled system, which operates entirely on diffusion. There are 2 ways to pull this off. Number 1 is the reservoir system. Picture a tiny water balloon with microscopic holes in it. The drug is the water in the core, surrounded by a special outer membrane, and it slowly diffuses out through that skin. Number 2 is the matrix system. So, instead of a core, the drug is completely mixed throughout a solid matrix. Think of this one like a wet sponge. The drug slowly and evenly diffuses outward from the entire structure of the sponge over time.
Next, we have the dissolution-controlled system. Here, the physical melting away of the pill acts as the internal timer. This happens through encapsulation, where the drug is trapped inside an outer capsule that slowly dissolves at a very specific rate in your stomach acid. Or it can be matrix dissolution, where a solid block of medicine and carrier materials slowly dissolves layer by layer, kind of like how a hard candy dissolves in your mouth, releasing the drug at a totally steady pace.
Now, this third one, the osmotic controlled system, is absolutely brilliant. It literally uses your body's own natural fluids as an engine. Step 1, water from your digestive tract enters the system through a semi-permeable membrane. Step 2, as that water rushes in, it creates osmotic pressure inside the pill. Step 3, that rising pressure literally pushes the drug out through a microscopic laser-drilled hole at a perfectly constant speed. It is, for all intents and purposes, a microscopic water pump operating inside a pill. How cool is that?
And finally, the ion exchange controlled system. This one is just pure, elegant chemistry. The drug is chemically attached to an ion exchange resin. It just sits there, firmly locked onto this resin until it encounters specific ions that are naturally floating around in your GI tract. When the conditions are perfect, they swap. Your body's ions attach to the resin, bumping the drug off and releasing it into your system. It's a literal molecular exchange program.
All right, let's wrap this up. Section 5, the bottom line, putting it all together.
To make sure we walk away with a really solid grasp of this pharmacological marvel, check out this ultra-short revision formula right from the text. If you want to memorize what this does, it's simple. CDD equals controlled release plus constant concentration plus less dosing, which all equals a better effect. It's a perfectly straight line of logic, from the engineering of the pill itself right through to your overall health and recovery.
Which brings us to the absolute most important takeaway from our source material today. If you only remember one thing from this explainer, let it be this quote: CDDS provides drug release at predetermined rate for prolonged therapeutic effect. It is no longer just about taking medicine. It's about managing the exact timing and the rate of that medicine to heal the human body safely and efficiently over a much longer period.
Which leaves us with a pretty incredible thought to ponder. We've gone from crushing up simple herbs to literally swallowing microscopic osmotic water pumps and ion-swapping resins inside a single capsule. If we can control a single pill this precisely today, what is next for the future of medicine? Next time you take a slow-release medication, I hope you take a second to think about the brilliant, tiny engineering happening right inside of you. Thank you so much for learning with me on this explainer. Keep asking those great questions, and I will catch you on the next one.